So ladies and gents, this should be Tuesday's video. This is like the 10th video I've made today, so I apologize right now if I get a little tired or a little punchy. But here's the good news. I'll be back tomorrow and we can review this stuff again today. So right away, you see that there are 2 warm-up problems. Pause that video right now and then I'll go through how to do it. Pause. Okay, so I'm back. And since I'm back, we are going to rewrite it. Notice this left side has 2 logs on it. You can only cancel 1 log on the left, 1 log on the right. So we are going to rewrite this side as log base 12 of x minus 2 times x plus 3. And it is, ooh, that looks like bad plus sign. And it's going to equal log base 12 of 6. Okay, so now that we have single log on the left, single log on the right, they cancel, and I'm left, and I'm going to FOIL this out because these 2 things are together. I'm left with x squared, and then you'll get a positive 3x and a negative 2x, so plus x minus 6 equals 6. Remember, it's a quadratic. X squared plus x minus 12 would equal 0. This is now a friendly factoring one, x plus 4 and x minus 3 equals 0. So I'm guessing that you can figure out that x is going to equal negative 4 and x is also going to equal positive 3. But wait, we need to do a check, and 4 does not work, that negative 4. Also need to check that 3, it works, so in this case, only one of my solutions actually worked. For the second one, notice this 3 is out in front. It has to go to the top. It's got to be the word single log. And there's subtraction. So this side has a lot of rewriting to do. Log base 5, the 2 gets cubed, but then there's subtraction, so that is rewritten as division. And it is 2 cubed over 8 and log base 5 of 4. Okay, so we've got single log on the left, single log on the right, and I can finish this. 2 cubed is 8 over x would equal 4. I'm going to multiply each side by x, and I am going to finish this with 8 equals 4x. X would equal 2. Okay. So now, make sure you do your check. Ta-da, works. Okay, so that was a review from Monday. I'm hoping that you're getting that stuff, and those weren't the easiest ones to review. So now today we need to take a look at what our learning target is. It says that we're going to solve exponential equations using common logs. That's our LOG. Tomorrow we get to use natural logs, a new log, and we're going to evaluate logarithmic expressions using something called change of base. Change of base is one of those things that I've got to show you, but there's a shortcut on the calculator. So shortcut on calculator. And I'm writing this down so you guys help remind me to show you that shortcut on the calculator on Wednesday in case I forget. Okay, so now we're going to actually really start using logs a lot. And the first thing that I want you to know is the base we sometimes neglect. Just like if I would write x, you guys know that that means that there's technically a 1 in front of that x. Well, if I don't write a base, it means it's in the base that we use every day, and we're in base 10. We have 10 digits, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then it repeats itself. So we have 10 digits in our counting system, so if it's not written, that's the unwritten rule is it's base 10. So I'm going to start to leave that base off if it's a 10, and you guys should know that. This is something that you just need to remember, and we'll use it a lot. Okay, so we are going to work with exponential equations again. We had those back a couple of days ago. So remember, for exponential equations, we said the first way that we could solve them is using something called a common base, and that's when we forced everything to be like base 2 or base 3 and the bases canceled out. Or I said the second way was where you were going to introduce log on each side. And we're going to introduce common logs, and then we're going to drop them. Okay, so I look at this equation here, 5 to the x equals 62. I can't solve it. I can't force a common base. I need to get that exponent out of, or that variable out of that exponent and down. So what I'm going to do is I am going to write log on the left side. And if I do something to the left, I also have to do it to the right. And when I do that, I now have the equation log to the 5x power equals log to this, 62. Now notice, this base I didn't write. That's base 10. I'm not going to write it. But remember, my goal was to solve for x. So when I have it in this form, do you remember the exponent rule? We used it backwards yesterday, but that exponent can come down in front. That is a rule, and when we introduced that rule, I said you needed to know it forwards and backwards, because now I can rewrite this as x log base 5 equals x log of 62. These are times each other. So how am I going to get rid of this log? I am going to divide each side by log of 5. And when I do that, I end up with x equaling log of 62 divided by log of 5. And this we're just going to do on the calculator. And on your calculator, you are going to hit log. It's going to look exactly like this. So on your calculator, you hit your log key, and then a box appears down here, and a box appears here. So, since I did not have a base on this, I'm not going to fill in this box. I'm just going to put the 62 right here. And you can set up a fraction, or you can do divided by. And then I'm going to hit the log key again. And when I hit the log key again, a box is going to appear down here. Oops, no pen. A box is going to appear down here, and a box is going to appear here. I have no base written, so I'm not going to fill out that base, and I'm going to hit that. And then, this is just a calculator problem. It turns out to be 2.5643. Now, I cannot tell you why, but with logs, we always take them to 4 decimal places. So get used to the 4, and if I want something different, I'll make sure I type the directions differently on a test or a quiz. So even reviewed how to do the log stuff on the calculator with you. Okay, we're ready to look at problem number 2. So for problem number 2, 7 to the x equals 20. I can't force a common base, so now I need to introduce log on the left and log on the right. And when I redo that, I get log, don't care about the base, raised to the 7x power is going to equal log, don't care about the base, to the 20th. Okay, well, why do we do that? Because that log allows that variable that's the exponent to be pulled down in front using those log rules that we had. So this is log x log of 7 equals log of 20. How do I get that x by itself? X is going to equal log of 20 divided by log of 7. Okay, punch it into your calculator and check to make sure that you have it. It should come out to be 1.5395. I'm taking a minute. I'm pausing. Check it, or you hit pause if you need more time. Okay, I'm back. Now, I am going to tell you, number 3 and number 4, these would be considered the hard problems for the logs. We're going to do the exact same thing that we've been doing. I can't get a common base, so I'm going to introduce a log on each side. And when I introduce a log on each side, this is going to take a little bit of work. You got to pay attention. Stay up with me. This becomes log of 3 to the x plus 1. And it's going to equal log 2 to the 3x power. Now, do you guys see that this whole exponent's going to come down in front and this whole exponent's going to come down in front? I'm guessing you can see it. But watch when I write it. That exponent has to stay together. So that's x plus 1 in parentheses times log 3 equals the 3x stays together log of 2. Oh, we've got to solve for x. There's x's on the left, there's x's on the right. So the first thing we have to do is free this x from the parenthesis. This is times. That means that I am going to distribute. And when I distribute, I get x times log 3 plus 1 times log 3. Now, I need to tell you, do I have to write the 1 there? I don't, but I hope that you see x 1 log 3 equals. On this side, there's no plus sign, so this just becomes 3x log 2. Okay, all of the x's are free now. No parentheses. We got x's on the left, we got x's on the right. You guys need to remember just common rules for solving. All x's on one side, everything else to the other. So this is going to move to this side. I'm going to do that by subtracting. Okay, so I get x log 3 subtract 3x log 2. Do you see how it went from positive on the right to negative on the left? And guess what? This also has to go to the other side because it doesn't have an x. Okay, so I did a lot of algebra right there, and this becomes 1 log of 3. And this is probably the last time I'm going to write that 1 in front of it. So hopefully you guys see, oops, what did Kendall forget? Her negative sign. So it was positive here, it's negative on the other side. The 3x is positive on the right, it's negative on the left. Okay, that's the algebra step, but now even harder algebra. If I have one term that has an x and a second term that has an x, we have to do everyone's favorite factoring. Or I'm sorry, we have to factor out that x. When I take an x out, this becomes log 3. When I take that x out, that becomes 3 log 2. And it still equals that negative 1 log 3. Almost done. How would you get this x by itself? Divide! X equals negative. If you like the one in front of it, you can put it there. If you don't, it's not going to matter because I normally don't. Negative 1 divided by log of 3, subtract 3 log 2. Now it's a calculator problem. So grab your handy dandy calculator. I would use the fraction key. And it turns out that x is going to equal 1.1200. Check it out. Okay, last problem. Again, this is one of those harder types. I can't force a base. So I'm going to get a log on the left and I'm going to add a log on the right. Got it. Okay, so log 3, and again, I don't care about the base, to the x minus 4 power equals log 5 to the x minus 1 power. Got it. Now remember, we made it this log so that exponent can come down in front, and so this exponent can come down in front. That's my goal. Okay, so in a parenthesis, the x minus 4 comes down in front, and the log 3 stays behind it. It's going to equal the x minus 1 comes down in front, the log base, or the log of 5 behind it. Now, we have to free this. So, since we need to free this, this is x log of 3, subtract 4 log of 3 equals x log of 5, subtract 1, I'm not writing the 1, log of 5. Okay, x is on the left, x is on the right, so just a friendly reminder that we're going to have to move this term to this side, and we're also going to have to move this term to this side. So, what does it look like when I do that? Okay, guys, sorry if you had a few clicks there. Just had to run and go do something quick. Okay, so the whole goal was that we were going to be moving the all the non-x terms to the right and all the x terms to the left. So when I do that, I get x log of 3 subtract x log of 5, but this time it's going to equal negative log of 5. That was already on that right side, and now a positive 4 log 3. Okay, we're almost done. Almost there. I got to get the x by itself. How do I do that? I factor it out. Take out the x, and I'm left with log 2. Subtract log 5 equals negative log of 5 plus 4, oops, I keep plus sign, 4 log of 3. Almost done, get the x by itself. X equals divide. That negative log of 5 plus 4 log of 3 is going to get divided by the log. This is an icky 3. I got to come back up here and finish that. That's a 3. That's a 3. They were log 3s. Log of 3 subtract log of 5. This is a calculator problem. It has to go in exactly like you see it. And when you do that, that's negative 5.452. Pause it. Try the calculator. I'm going to say about a third of the people goof up the calculator stuff. Okay, so go. Pause. Okay, so now we're back. And we've got to do something called change of base. Change of base formula was actually created before we had our fancy end spires. And this is the only way we could do something if it didn't have a base of 10. Because everything that we count is base 10. If it's not our base, couldn't do it. So the rule says the base goes to the, we can rewrite this as two separate logs in division. So this base of 3 goes to the bottom. I always write base to the bottom. The B's have it. Base to the bottom. Okay? The arguments on top. ARGU. I have a hard time spelling on this thing. Argument to the top. Okay, so notice for this example, you see how my base is to the bottom? On the bottom, I'm going to write log 4. Now, notice I didn't put a base in here. It's a base 10. I'm not writing them anymore. And then a log of 23. You plug that into your calculator, and that will tell you what log base 4 of 23 is, and it should come out to be 2.2618. Go try it. Okay, you tried it. Log 14. Base to the bottom. That's log base 14. Base to the bottom. And the argument on the top, 2/3. Go plug that into your calculator now. Make sure it's exactly the way it is, and you should come out with negative 0.1536. Okay, pause. Try it. Okay, you're probably back, and I'm going to tell you to probably pause it again because now you need to try these things. So these are the two new types of problems that we had today. The first, 1 and 2, are exponential equations. Notice there's an equal sign in it. I have to solve what x equals. So I can't, you can pause me now and then come back and check your answers. So what I see is I need to introduce a common log on each side because there's no way for me to get that x squared out of that exponent without it. So introduce the log on each side. So I'm going to have log of 25 raised to the x squared power equals log of 50. Okay, that means that this x squared now can come down in front because that's one of my log rules. So I get x squared times log of 25, and it's going to equal log of 50. Almost done. X squared equals log of 50 divided by log of 25. And now something that we did not do in the notes, but I assume you remember. How do you get rid of a square? You're going to square root it. And when you square root this, you put that on your calculator. So x is going to equal the square root, and then hit your calculator or your fraction key and do log of 50 over log of 25. And that should give you the decimal of 1.1024. Okay, second one, a little bit harder. We're going to put a log on each side. And when we do that, I am going to have log of 5 raised to the 4y plus 1 power equals log of 32 raised to the 2y power. Again, we do that so you can see the exponent comes down in front and the exponent comes down in front. Okay, so since there's a plus sign in that exponent, that 4y plus 1 stays in a parenthesis, log of 5, and it's going to equal 2y times the log of 32. I have got to free the y, so 4y log of 5, I'm distributing that parenthesis, add it on to 1 log of 5, is going to equal 2y log of 32. Okay, so non-y terms come to the right side. Y terms come to the left side. And when I do that, I get 4y log of 5, subtract 2y log of 32 equals 1 log of 5. Pull out the y, factor it out, and I'm left with y times log of 5, subtract 2 log of 32, and it equals 1 log of 5. Almost done. Y equals 1 log of 5 divided by a log of 5, subtract 2 log 32. And when you do that on your calculator, you should get 3.2598. Almost done. Okay, this is not an equation. This is going to be a change of base because it's not equal to anything. Okay, change of base. Remember what I said. The base goes to the bottom. Okay, log 15 is on the bottom, which means the argument's on the top. Log of 5 on the top. Go punch it into your calculator, 0.5943. Last one, log of 11, log of 104 over log of 11. I always usually do the bottom first. Base is to the bottom, base to the bottom. And when you punch that into your calculator, you come up with 1.9369. So tonight, your assignment is worksheet number 6. You got to try them. Try them, and here's the best thing. Tomorrow I'm back, and you can ask me all the questions that you need to. So good luck tonight. I will also have the answer key to worksheet 6 posted, so you can check that. I will see you on Wednesday. Good luck.